Zoom. Okay, welcome, Rabbi Yitzchak. Okay, that's what I call you because you have so many syllables in your last name. Nice to see you again. Welcome back. You, of course, were a Talmud in the course years ago. You taught the course a few years ago.
Yep.
You and your wife are both working in the field, doing wonderful things. It's really a pleasure to have you back with us. As I said, we have two classes here tonight. One group have been going for 2 or 3 months. The other group is two-thirds of the way done through the course. And so I would love for you to share with them what you do in a SIMSOC and, sort of understand that because as you know, it's a great pathway to get into the ecosystem of cyber, no matter what a person ultimately wants to do, even if they want to do even GRC, and certainly if they want to do pen testing, to be in like the nitty gritty and to see the logs and the attack vectors that are coming in the SOC, I think is a great way to get started. But without further ado, Rav Yitzchak, I'm turning over the floor for you to share with our students tonight. Thank you so much for being here.
Okay, great. Thank you. Let me share my screen. I hope this is gonna work. Okay. Can you see my screen? Yep. Okay, great. And you're seeing like okay. So hi everybody. My name is Yitzchak Shevinovsky. We're gonna be discussing about SOC and SIM today. So first, we're going to talk about three things. One is who I am, the importance of cybersecurity. I'm sure you've heard it a lot over the past however long you've been in the course, but just another perspective, and also kind of some goals that we want to reach after at the end of the hour. Okay. So first of all, my name, like I said, is Yitzchak Shevinovsky. I am a senior staff security engineer at Palo Alto Networks. Palo Alto Networks, for those of you who are not aware, is a multinational company that sells a lot of different cybersecurity products, primarily the NGFW, the Next Gen Firewall, is their flagship product. They also have a lot of other products since then. They're pretty much their processes by some startup and incorporated into their products. So they have different sections of products. One of them is Cortex, which is primarily what we work with. Within the Cortex family of products, we have XIM. XIM is a SIM, which is what we're going to be discussing tonight. And that's what I'm working with on my day-to-day. Although my technical name is senior staff security engineer, I think I have some other name within the organization, but it's basically an analyst. That's basically what it's supposed to be. Okay, so that's pretty much. Oh, actually, before I went into cybersecurity, I should actually give a little backstory. Before I went into cybersecurity, I was learning in Palo for about 10 years, give or take. I would give some extra, maybe like 12 years, something like that. We reached a situation where we needed to bring in some extra money. We got an random email, I don't even know from who anymore, saying that somebody's starting up this cybersecurity course. We didn't even know what that meant. My wife said, try it out, can't hurt. I said, okay. And I took the course. There was actually two courses at the time, one for men and one for women. There was at the time. My wife took the women's one, I took the men's one, but then I decided to also take the women's one. So I kind of like connected to her computer while she was taking the women's course, and I was able to get the best of both worlds over there. And then the following year, so I really enjoyed it. I spent a lot of time studying up on it, learning it. And then the following year, I actually gave the course for quite a while. Okay, so now cybersecurity is really, really important for organizations that are big and small. Now, normally you only really see this spoken about in medium to large businesses, but it's definitely something that's relevant for small businesses as well, because cyber attacks today are so advanced that there's not even anybody on the other side of the computer that's trying to hack in anymore. It's just scripts that are just going through the entire internet and just trying to hack whoever it can find. So there's not really any reason to say, okay, like this big organization, that's the guy who needs to be worried about this. It's true for everybody. Every small business, small, medium, and large business needs to worry about cybersecurity. Attacks are very sophisticated, um, unbelievably so. We have APTs, which maybe some of you have learned about, some of you are going to be learning about, who can spend months building up entire infrastructure within a network, getting access to different places. You think that you've kicked them out, and they actually have some other way to get back in, and it's just like a very sophisticated cat and mouse game. It's very costly. Cybersecurity is very expensive, both if you've been hacked and if you want to prevent getting hacked. It's really just you're going to have to pay some way, probably better to pay without having to, lose all of your data, breach customer trust, and things like that. Aside from that, it's gotten more important because a lot of businesses today have a remote work or hybrid model, which is something that we have. We've actually been remote, and now we're kind of moving into hybrid at Palo Alto. That opens up a lot of attack vectors because people are not within the network, they're coming from outside the network. That means that they're not within your infrastructure, within your firewalls. They can, patch in, but they're not starting from within your network. A lot of cloud adoption is really been a huge attack vector in Palo Alto networks. The majority of our logs that we ingest actually come from cloud service providers, by far the largest majority. And we're talking about 15,000 employees. And the 15,000 employees are not what's generating our logs. It's the cloud service providers that are actually generating the majority of our logs. So as businesses have moved into the cloud over the past 10 years or so, that's opened up many more attack vectors. Now, as we're moving into AI and machine learning, there's additional attack vectors that are starting to open up that we've begun to create different types of security devices to protect against those vectors. Aside from that, one of the other things is that it's not like a threat actor today can be, one guy called a script kiddie, for those of you who may have learned it, the newest guy on the internet who's just running a bunch of scripts, all the way up to nation states which have their APTs. So there's a large amount of broad spectrum of different types of threat actors out there, all with their different reasons why they're trying to hack, whether it be for political reasons, money, or what have you. Or in the case of, I'm sure you've heard of some of the other cases, like, for instance, the very famous worm that was developed, supposedly, I don't think it was ever admitted to, but developed jointly between America and Israel, which was able to destroy the centrifuges in Iran. That was probably the most advanced attack that maybe even still today, just in terms of how advanced the actual worm was. So there, it's not being done for necessarily to try to get money or something. It's actually it's more of a defensive mechanism. So the point is that there's a lot of different reasons why threat actors are acting, and it's important to be able to protect yourself from all of them. And then, of course, you have regulatory things like GDPR, HIPAA, that you have to have a strong security posture in order to be able to get certified. If you want to be able to have anything going on in the medical field, you have to have HIPAA. If you want, you have PCI DSS if you're working with credit card companies, and all those different regulations that are out there that demand different degrees of regulations and certifications. FedRAMP, if you work in the government in the US, Um, so beside, and then of course there's the actual trust that you might have with your customers, with your vendors. Your reputation is at risk if you're, the SolarWinds. If any of you have ever heard of the SolarWinds attack, that was terrible. It was a terrible attack because of the not just because SolarWinds was a vendor that passed on the malicious software down their chain, but also because it destroyed their reputation. Now who wants to work with a vendor who was the cause of such a huge breach of security? So, so all of those things are reasons why cybersecurity is very, very important today. So what do we do in a SOC? The SOC, now there's SOCs that are internal to a company, there's SOCs that are external to a company that are like MSSPs. An MSSP is basically like a third party that will basically give you SOC service. And I don't remember what it stands for, but it's basically, that's what it does. MSSP they have their pluses and their minuses for smaller businesses where you can't necessarily afford to have a SOC within your company because of the added costs. An MSSP might be a valuable solution for that. But otherwise, a SOC is like an in-house place where you basically do everything within your company. But this is the truth. This is true for all large companies. And what we do normally is we have 24/7 monitoring. So of course, for us, we do it 24/6, and then we switch. We actually have an American team who takes us over. So we're actually not working 24 hours a day. But in general, the actual service that a SOC provides is a 24/7 service, whether you're in-house or not. It's a 24/7 monitoring. You have detections and incident response. The typical roles you'll find in a SOC are the analyst, the manager, and potentially an engineer, depending on the buildup of the SOC, what type of SIEM you're using. We'll see there's different ways to build a SOC, and that will really decide that. But generally, you'll have your analysts and your manager, and the engineer role will either be kind of absorbed into the analyst role, or it'll be a completely separate role. So these are the basic the two ways that you normally find SOCs. You have your SOC manager. In the traditional SOC, you have the SOC manager who has 3 tiers of analysts under him. Your lowest tier is your tier 1, which is responsible for triage. An incident comes in, the tier 1 will come and say, okay, what's happening over here? Is this a real event? Is this something, how severe is it? And they might be able to do some initial work on the incident, and then they'll pass it up to tier 2 if they decide that it's something that needs to be responded to. Once you get to tier 2, so then you'll have like the serious incident response, where we've recognized that there is a real incident over here. They might put out what they call a SOD, a spreadsheet of doom, where they'll basically start mapping out all of the details of the incident, creating timelines, finding artifacts, and all of that. That will normally be within the tier 2. And then if there's more advanced need to investigate, so you'll have your tier 3 who can really like just know everything that needs to be known. They'll also take a more proactive response state, like they'll be doing what's called threat hunting. Threat hunting is where you will kind of like move through the network and try to find things that might be a problem. So potentially you'll be looking for things that you're not getting picked up in your SIEM, but you're not picking up because either it's too hard to create an alert for it, or because you're just checking to see if something is there. You'll basically have these different hunts that you'll do, and try to just find things that have not yet been picked up. So the tier 3 kind of takes that more proactive role. in comparison to the first two tiers, who are more reactive. They are kind of waiting there for the incident. But they all kind of work together, and that's your basic analyst tiers in your traditional SOC. And then you may also have, if it's not kind of like absorbed into the analyst role, you'll also have like a separate role, which will be that of the SOC engineer, the role of the SOC engineer, which is basically to make sure that the logs are getting ingested correctly, setting up new ingestion for logs. Now, a SIEM could be on-prem or a SaaS application. So the SOC engineer will be responsible for, if it's on-prem, they may be responsible for the resources that are needed for the SIEM to make sure it's running. On-prem on-prem SIEMs have a tendency to malfunction, so they, and SIEMs can be really complicated. So it'll be their responsibility to make sure that it's running. And basically, the more, not exactly the security needs of the SOC, but more the peripheral needs for the SOC. In the non-tiered SOC, which is actually the type of SOC that we have in Palo Alto, we actually have two completely separate teams. We have the SOC team and we have the SOC engineering team. The SOC team has no tiers, so everybody is expected to know how to do everything from tier 1 to tier 3 in order to be able to work in that SOC. We have like threat hunting programs where any analyst will just go and work on the threat hunting that's besides for the incident response that we provide. So an analyst in this kind of like non-tiered SOC has to be able to fulfill all of those roles. And the reason why it's actually kind of gone in that direction is because, which we'll see a little bit later, the advancement of the SIEM over the years has allowed for the analysts to spend more time on other things besides for triage, which used to historically would have been a very large, time-consuming thing to do. And then we have also the SOC engineers. The SOC engineers, which I actually happen to have worked as a SOC engineer before I became an analyst. And so the SOC engineer is similar to the role that I mentioned before. They were responsible for ingesting logs, making sure that the SIEM is working, setting up. Also, we have automation, which we'll talk about in a little bit, which is also the responsibility of the engineers, and basically kind of like assisting the SOC, the analysts in their day-to-day and in anything that they need. So like the analyst might do the actual security investigations, but the SOC engineers will facilitate those investigations in very, very important ways, to the extent that I know, like in the deck for Palo Alto, and Palo Alto is trying to get a customer, they bring up the point how the role of the engineer is in the SOC today, especially using the SIEM that we use, is so important that it kind of, we're able to limit the number of analysts that we need by adding more engineers, which is good, because you don't need to have that necessarily. You don't need to have that security knowledge. You can just get away with having enough of the knowledge that you need to be an engineer, which kind of opens you up to a bigger pool of prospective employees. So for hiring, that makes it a little bit more convenient. So that's kind of like the SOC that we have today at Palo Alto, and it's also fairly typical SOC. But these are the two main types of SOC that exist today. Does anybody have any questions about anything that I've said? By the way, I mean, there's only a few of us here, so we could kind of keep it personal. So if anybody has any questions about anything I've said, please just unmute yourself. Okay, so that's pretty much what a SOC does. We'll get more into that in a little bit, but let's talk a little bit about the SIEM, or some people call it a SIEM, whichever you prefer. The SIEM, which is I don't even remember anymore what it stands for, but I'm sure you could quickly find that out. Security, information, and something management. something along those lines. So what the SIEM does is it's basically responsible for log collection, which incidentally is something that you don't need to have a SIEM for. There's Elastic, for instance, and Datadog both have log collection management products that are irrespective to their security section. And where the SIEM part comes in is where you have your correlations. That's where you start to become security oriented, because what the correlations are is you're taking all of that log, all of those logs that you've collected from all those different sources, which we'll get into, and you're iterating through those logs, and you're generating alerts based on activity that you're seeing. And we'll see examples of that. But that's where the real that's where the SIEM part, the security aspect of the log collection platform, which is the basis of every SIEM, really becomes security oriented. That's where you're generating correlations, you're taking, or alerts or incidents. How every SIEM has its own nomenclature, but you're taking those logs and you're generating those correlations, you're generating those alerts. You're finding activity that's either suspicious or definitely malicious based on the logs that you're seeing. And that's really what the SIEM is all about. There's a bunch of companies that put out SIEMs. Some of the more popular ones are Splunk, Sentinel, QRadar. I think QRadar was actually bought out. So I'm not, I think QRadar might be going into end of life. I'm not 100% sure. Elastic has also has a SIEM, if you're familiar with the Elastic Stack. So that's a very popular open source log shipping platform. There's and then there's, of course, there's Cortex XIM, which is the SIEM of Palo Alto, and the SIEM that we use in Palo Alto. Where our main competitor happens to be Microsoft Sentinel and Splunk, I would say. Splunk is basically the biggest, most widely used SIEM out there. It's an on-prem SIEM, so basically you have to host it yourself, although they do have an option to host it in the cloud. But essentially it's just the virtual machine that's just hosted in the cloud. As opposed to that, Microsoft Sentinel and Cortex XIM, there's also Google has Chronicle, I believe. Those are SaaS platforms which makes upkeep so much simpler, because you're not responsible for that, because it's a SaaS platform. So you're just responsible for getting your logs there and then doing it whatever you want with them. And in that respect, Cortex XIM and Microsoft Sentinel are more competitive, because they're both SaaS platforms, as opposed to Splunk, Elastic, QRadar. Datadog happens to also be a SaaS platform. So these are some of the more popular ones, but there's tens. There's many. Personally, I've worked with FortiSIEM. If you've ever heard of the FortiGate firewall, FortiGate also put out a SIEM, which it's quite old and not easy to use at all. I didn't enjoy working with it. There's also McAfee, if you're familiar with McAfee antivirus. So they also have a McAfee ESM, which also might have been bought out at this point. Also pretty old. I've also worked with QRadar, which is easier, but very complicated. And I've worked with Sentinel. So Microsoft Sentinel is Microsoft, right before I worked with XIM. So I was responsible for Microsoft Sentinel. And it was more enjoyable to set up and to work with. And it's somewhat of a different, feels a little different, but they're both really good. And then today, for the past few years actually, I've been working with Cortex XIM, which has its ups and downs, but it's a nice platform. Okay, so this is really the main slide of this speech, of this talk, because this is really what the SIEM is all about. You have all of these different logs, and I give some examples over here, and where you have your network logs, endpoint logs, cloud logs. Those are your main categories of logs. In the network logs, you'll have firewall logs, single sign-on logs, mail gateways. For example, on endpoints, you'll have your EDR or your XDR, Windows event logs, application logs, because endpoints can be servers, they can be users' laptops, and you have your cloud logs, which again, as I mentioned before, is definitely by far the largest number of we take in I think 90 terabytes of logs a day, and about 65% of those are just from one cloud service provider. So we're talking about just a seriously vast amount of logs, billions of logs that we're ingesting every day. You have your CASB, your Cloud Access Security Broker, data loss prevention, which may be cloud-based, maybe network or endpoint-based, really depending on what type of DLP you have. And then besides for all of those logs that you're getting, you're also getting other additional information. So you're getting your threat intel. Your TIP is a threat intel platform. There's many threat intel platforms that are out there. Intel 471 pops into my head. We have Unit 42 as Palo Alto Networks one. There's many others. And then you have your attack surface management tools, which are basically running through your whole attack surface, meaning all of your assets that you have, and kind of letting you know what their status is. Maybe they need patches, maybe they have ports that are open that shouldn't be. That's really all coming into your SIEM. The SIEM takes all of that data, it correlates that data, and we'll talk a little bit about that. It generates an alert, and then somebody's going to have to respond to that alert. We'll see who can respond, how you can respond, and also later on. But that's, in a nutshell, this right here is pretty much the entire overview of how the SIEM works, what the whole story is with SIEM. That's basically right here. We're including a lot of data here because it really includes a lot of different things. How you ingest those logs is very, very important. One of the difficulties with any SIEM, one of the big hurdles is getting your logs into the SIEM, because there are so many ways to ingest logs, and not every application or product makes it that easy to ingest logs. So getting your logs into the SIEM is actually a very big hurdle. Generating correlations, we have in XIEM, we get 5,000 correlations just out of the box, but we spend a lot of time making our own correlations that are relevant to our own network, as opposed to just more generic ones that are useful for any organization. So correlations are a big part of our day as well. And then we spend a lot of time responding to alerts. Not too much time, and we'll speak a little bit about why that's the case, but this is pretty much the entire breakdown. So just to give you guys a little bit of an example of what log ingestion means, let me see if I could switch to this here. Okay. So I didn't have a lot of time to create my own log, so I actually just went to ChatGPT and asked for. Yeah, go ahead.
Could you just say a few words what you mean by correlation?
Okay, so a correlation is actually where you take logs. We're going to actually see what that looks like, but you take logs and you apply some logic to it to generate an alert, to either because something suspicious is happening or something that's definitely malicious is happening. That's what I mean by correlation. We'll actually get into that. We'll speak about it. So I just wanted to give you an example of how logs look. This is, again, the raw log before it comes into the SIEM. Once they come into the SIEM, they are generally put in a easier to read format. But these are just generated logs. Again, I didn't take them from my company, or I would be in very big trouble. I asked ChatGPT to generate them, and I verified that these are actually the correct format for these types of systems. These are systems that we have in Palo Alto Network. So Okta is an SSO, a single sign-on. If anybody's not familiar with single sign-on is basically where you can sign in through one application, and that application will allow you to sign in behind it to many other applications. So this way you only have to like sign in once rather than sign into every application's on its own. That's useful for the user because this way they don't have to remember different passwords or have to go through sign-in steps every single time they want to go into another application. It's also useful for the SOC because this means that we definitely know what every user is accessing. We know if a user is logging in to any given application that they log into. You can see that we can tell where they're logging in from. We have their IP address. We can tell the user if they were successful or not. Not always are they successful. Definitely not always. How they logged in and other information. This is one example of a log from Okta, from that single sign-on, which is basically telling us that this user used whatever agent, used Chrome to log in, which is pretty straightforward. This is the actual log. It's in a format called JSON, which is a very popular format, and I think over the years it's become more common. It's very easy. It's easier to read for sure. Easier to understand what's happening in that format, and it's easier to standardize. So this is a very popular log format nowadays. So this is a log from Okta. This is one example. Now here we have another log from AWS CloudTrail. So AWS, not Amazon, doesn't only have a marketplace; they also are a cloud service provider. And this is a log showing an EC2 instance launch. Anybody have any idea why that might be interesting for us, or anything in this particular log that might be interesting? If you could see my screen well, I don't even know. Is it big enough? So over here we have somebody launching an instance. An instance over here means a virtual machine within the cloud service provider, within AWS in particular. The instance type is a C59X large. That's a very large instance, a very large virtual machine, which as a analyst would be interesting for me, because what if an attacker is spinning up large instances for crypto mining? A small instance is not going to be really useful. They'll generally set up these very large instances. So I would definitely, as an analyst, I would definitely want to be alerted if there's or multiple even large instances being spun up. That doesn't mean that every time that a large instance is spun up that it's something bad. I mean, it happens all the time. It's a natural part of a process in a large company, but it's definitely important for an analyst to know that there are instances being spun up. There are large instances being spun up, and by who, in which account, which user is spinning them up, what access key are they using. Over here, AKIA indicates a long-term access key, which you generally wouldn't want to give to a username. You would usually want to put your long access keys to roles rather than users. So whoever set this up, again, this is just a sample, but whoever set this up, we would have asked them to assign this access key to a role and then have the user assume that role when they need to perform some type of activity like this. We know where they're doing it from as well. So all this information is found in that log. And again, you can understand why that it's important for the SOC to ingest this type of log. Which is not to say that all of the information there is important to us, but a lot of it is. Okay, here we have a Windows security log. Now this one's actually kind of easy to show you, because if you ever want to look at your own Windows security logs, you can do that. You can just, if you have a Windows computer, you can check out the event logs within Windows. You'll see logs like this. Probably not this particular one because this is privilege assignment, which you'll only see within a Active Directory environment. Over here we have the computer. We have the user. So somebody named B. Smith was given these privileges, which are actually admin privileges. So this is again something we would want to know. Again, especially so within our environment, because we wouldn't normally expect a normal user to be assigned these admin type of privileges. These are all admin privileges, and this user is not an admin user. We can tell when a user is an admin user or not because they'll have some prefix or suffix indicating that they're a user. In particular, we do ADM dot and then the username. So if this was an admin user, we would expect to see it like this. Nope, not like that, like this, like that, like this. So the fact that we see that this is just B. Smith, who's getting these admin privileges, would be very, very rare and very interesting to us as analysts. So you can see why it's very important to have this type of Windows security log, event ID 4672. If Windows event IDs and Windows event logs are a very significant part of any SOC because Windows is everywhere. So again, it's pretty understandable why we'd want to ingest this type of log. And you can notice also that the format is different. So over here we were looking at like JSON formatted logs, right? If anybody's familiar with any programming, so you might be familiar with JSON from programming. This format is called XML. It's a format that Windows uses for their logs, and just kind of looks like this. It's not the easiest to read. It's not the easiest to extract data from, but that's all we got. So that's how it looks. But if you look at it within your event viewer, it won't look like this. You can get the event, the XML view, but there's actually a easier to read view that makes it a little bit easier on the eyes than this. So yeah, but this is the Windows event log, and I'm going to give you an example of how it's going to all look once we go into a SIEM. But just to know that there are these different formats is important to know, to be aware of. So this was the AI trying to generate a XDR log. XDR is a type of, it's supposed to be the new next generation EDR. It's called XDR. It was kind of trying to generate an XDR log. XDR logs are actually significantly longer than this, so it's definitely not the full log, but it does have the important points over here, which we see over here that there's a process name called chrome.exe that was generated by explorer.exe. Explorer.exe is the process for Windows. So somebody basically just double-clicked on chrome.exe within Windows and began doing whatever browsing within Chrome. It is possible to see, again, like I said, that this is not the full event log for XDR. The full event log would be much larger. There would be another few rows much later down that would tell us, for instance, what information is in the tab. Like, let's say over here, you see how I have up here logs Google Docs. So it's actually possible to pull that name into the log. So it's kind of useful because I'll be able to see which Chrome tabs they have up, like what they're looking at in Chrome, because whatever appears up here will show up in the log over here as well. But just looks like ChatGPT just wasn't aware of that or wasn't able to do it. We'll also have, very important, we'll also have the process hash. That's really, really important, because when you are investigating an incident and you don't know if some application is malicious or not, the first thing that you're going to do is you're going to take the hash. And I am assuming that you've all learned about what hashes are. If there's anybody that hasn't, please, unmute yourself. But basically, we would take the hash. We would go to, let's say, virus total, and we would put the hash in here. and it would tell us if it was a malicious hash or not. Basically, what would happen is someone else who's seen that process or application before me would have uploaded it to VirusTotal, and VirusTotal would generate a report on that, and then we would be able to use that information to determine whether the process was malicious or not. So over here, you can see that the actual the path for the application is the actual path, the true path. But if I were to find a chrome.exe in some other location, it might be a suspicious location, and then I might wonder, is this the actual Chrome? So I would take that hash and I would pop it in there, and it would kind of tell me if this is the normal chrome.exe, or if this is a malicious file that's kind of masquerading as Chrome. Here we have a vCenter log. So again, we're moving out of the JSON format, which is kind of this. This is a syslog format. This is another type of format. In particular, this is RFC 5424. You could tell that it's that because it has this part tacked on in the front. A syslog is basically you usually see it by Unix or Linux-based systems when they're pushing logs. And we basically have a timestamp over here, all the way to here, actually. Well, this is the timestamp. We have the year, month, date, time, and then the time zone. We have the host that forwarded the log to me. We have the process name, the process ID, and then we have the event. This is basically the log. So basically everything from like here on is the body of the log, where I can see that at this particular time, somebody performed this VM cloned event, right? This would be the user over here, admin user. And it looks like they cloned the image DC to DC06 on this host in this area. Now, if you're not familiar with vCenter, for anybody that's not familiar with vCenter, vCenter is, if you've worked with VMware, have you worked with any of the VMware like Fusion or Workstation, where you're able to basically put up virtual machines within your computer? So vCenter kind of allows you to do that, but much bigger. So like you would, rather than putting it within your Windows machine, you would actually, the operating system would be from VMware, and you would have like vCenter running in there. It could also be running actually in Windows machine, but you probably don't want to waste the resources to do that. But the point is that what vCenter does essentially is that it hosts virtual machines. Very important, usually important virtual machines. We have multiple vCenters set up in our network, and we see that somebody cloned a VM. Now, again, as an analyst, I would be very interested to know that somebody is cloning an image to a DC, because the DCs are, the crown jewels of an organization, and I would definitely want to be aware of somebody doing that type of activity within our environment. So now after that, one second. Okay. Besides for that, we have, so that's just another example. You can see that this is another log format, and there is a point to seeing all these different log formats. After that, we have the NGFW log. NGFW is just an example that I picked out. It's the Palo Alto Networks firewall. This is in another format. I specifically wanted to show you an additional format. This is called CEF. It stands for Common Event Format. And basically, this right here is the CEF header up until about here, I would say. This is the CEF header, where you have these different fields that are predetermined, and you kind of have to know what those fields are. You can see that this is a traffic log. running on PanOS because that's NGFW, belonging to Palo Alto networks. This is the version of the firewall that's running. And then you'll start with the actual information, and the step format is kind of in this like key value format where you have the key is source, and here's the IP, here's the destination IP. We have the source port over here, destination port. I don't know why this looks like this is a DNS IP address with 443, which is HTTP with HTTPS, which doesn't really make any sense, but that's ChatGPT. We have it was allowed for web browsing, which that part does make sense. And then you have the kind of annoying part over here, which you have these like labels. So like the label, here's like one label, CS1 label is rule, and then the CS1 field is allow. So this is really where the annoying part of CEF is, where you have these like the field name and the field value are broken down into two separate values, which makes it really annoying, especially if you need to extract the data. And then goes pretty much along those lines. Here's another one. This is another syslog format called RFC3164. This is access management on Ubuntu, running from the SSH daemon. There's an authentication failure by the user root. Remote host is this one right here, trying to get in over SSH, and he failed to authenticate. And again, this is another syslog. There's 2 or 3 major syslog formats. Then you have the Apache web server. Web servers like host web pages. This looks like we have a GET request going to the admin URI. They got a 404, which means that it didn't exist. So obviously somebody was trying to reach a page that didn't exist using this user agent, and this is probably the URL that they were trying to hit. So again, another log format. There's actually a few different log formats for web servers. There's Microsoft IIS also has a bunch of different web log formats, which kind of complicate things. You could also customize it, which complicates things even more. And then you have your DNS server log. So this is from Windows DNS. This is a response event. So we should have over here, we have the send, which means the DNS server is sending the response back to this client. The request was for example.com, and the answer was this IP address. So this is basically a log that the DNS server is responding to after getting a request for example.com, asking where that IP address is. I mean, what the IP address for example.com is, and it was getting this response in return. And the last one that we're going to look at is this sysmon event log. This is just showing a process creation. It's in key value format. Sysmon is a very useful tool if you don't have an EDR. It allows you to generate logs on very deep logs on important processes, which you normally wouldn't be able to get. So over here you have the PowerShell. Somebody ran PowerShell, and it gives you the command line, which is actually amazing. Is anybody familiar with PowerShell? I know that some people are a little bit more technical. Anybody familiar with PowerShell? You, Michal, you're a little bit familiar. So if you see this flag over here, the encoded flag, this is actually something really important, because what this is base 64. I'm sure you either learned about base 64 or are going to be learning about base 64. Base 64 is a type of encoding that you can do. There's a bunch of different there's base 16, base 64. There's a bunch of other ones. What's important about this is that somebody didn't want to write out their entire command line for some reason. So instead they encoded it in base 64. And you could imagine that if somebody wanted to add some types of flags or arguments that are potentially malicious, by encoding it in base 64, it would be that much harder to find, because if I'm looking for specific, let's say, keywords in command line, I'm not going to see it. I'm just going to see this like random bunch of alphanumeric code, this alphanumeric string. So it's really, this is, you know, something that that an attacker might try to do. So having this command line here, being able to see the command line is actually super important. We can take this and go to Chef here. This one, Cyber Chef. We can take that. Cyber Chef has all these different really cool tools. Could put that in there. We'll take it from base64, and we can see that, you know, this is like this is basically what was encoded over there. But we would never know that if we were just looking for keywords and not looking for this, for let's say encoded command line, we would never know about this. And you can have, and if you're familiar at all with base64, you can have these like really long segments of code that you're running in there. And I've seen it. I've seen these like, you can have, it'll just be a longer base64 string. And you could basically hide anything there. Yeah, go ahead, Michael.
If you say that you know this, and this is a standard format, and you have this encoding thing, why can't you just automatically just decode it? It's base64, so it's more or less open.
Yeah. No, we do that. Of course, we do that.
Yeah.
But it's first of all, that's more of an advanced, not super advanced, but it's another way of obscuring the attack that an attacker might do. Not only attackers, it could be a legitimate thing that somebody does. If you have a really long script that you want to run, you might want to use base64 to just make it more compact, because it'll, you know, you can take this like script like this and just make it into a few lines by encoding it in base64. So there is a legitimate reason to do it. But you're right. We are alerted for anybody encoding their command line. We definitely are alerted to that, but it's just another level of obscurity that an attacker may try to introduce, because maybe you didn't. Maybe this one time, maybe you were alerted that it was encoded, but you decided, you know, it looks okay from the outside. I'm just gonna mark it as benign, you know. So it's just another layer of obscurity. So that pretty much covers all the logs, the different types of log types. And again, the point over here was kind of like to just give you an idea that their logs come from sources all over the place. They have completely different formats, and they give you really important information. But getting that information could be kind of difficult. Let's go back to the presentation. Oops. Okay, so we were over here. We have a couple minutes left. Okay, so how do we take all of that? And are you still asking me a question?
Yeah. I'm just wondering in general, who are your direct clients if you work with a cloud service provider? Is it the actual service provider, or is it clients using the service provider?
I'm not sure I understand. Who is the you? And
who is the direct client for your work?
So we are an internal SOC, so we are securing our own environment, which includes our environment within the cloud that's provided by our cloud service providers. We actually have 3. We're working on now on our 4th cloud service provider. So we have AWS, Google, GCP, and Microsoft Azure, and now we're working on Oracle as well. This is basically where we host our entire infrastructure. Our client is ourselves. We're an internal SOC, and that's normally what a SOC will be. But it is possible, again, like I mentioned earlier, you can have an MSSP, which will be, the organization is just this SOC, and they provide services to clients. That could be, you know, any business can hire an MSSP to perform SOC services for them. Does that answer your question?
Yeah, I think so. So it's not, if it's GCP, for example, it's not GCP itself, it's clients using the GCP.
Right. So clients have their infrastructure within GCP, and the SOC would be monitoring that infrastructure. Yeah.
Okay.
Yeah. So together we have the SIEM provides the data, the SOC responds. Our workflow is that logs come into the SIEM correlates it, generates alerts, and the analysts respond to it. And now we're going to give an example of how that actually comes together. So we've seen the logs, and now here's how it looks after we've ingested those logs into a SIEM. Again, these are generated samples. They are not actual logs that I would get in trouble for posting if they were real. But this is a sample of brute force logging. Okay. Anybody want to venture what's happening over here? Venture a guess. What might be happening? Okay. So what we have over here is we have the timestamp. Oops. Back. We have the timestamp, which tells us when the event happened. We have the host name that it was happening to or on. We have the event ID, which was something I mentioned with Windows event logs. This right away tells me that this right here tells me I'm looking at Windows event logs, because event IDs, these are like very popular, well-known event IDs, and logon types is something that comes with Windows logs. So I see over here that a user failed to log on, which, sounds okay. The user was admin, and he came from this source IP. Okay. This was at 2:03 in the morning at 12 seconds in. At 13 seconds in, there's again the same failed to log on by some other user coming from the same IP. At 14 seconds in, again, a different user, 15 seconds, 16 seconds, 17 seconds, 18 seconds. Now, if this is not obvious to everybody, it's impossible, not completely impossible, but very unlikely that a legitimate user is going to be trying to log in to somebody's Windows machine, to this, Windows machine right here. Somebody's going to be trying to be logging in from all these different users. Usually you have your own user, and if let's say you failed to log on because you messed up your password, you might try 1 or 2 or 3 times, but using the same user. If you made an error in how you typed your username, so you might see like 2 similar users grouped together. But that's not what we're seeing over here. We're seeing completely different users, and the names of the users that are being attempted over here are also kind of suspicious, like admin, administrator, guest, sysadmin. These are users that you would typically possibly find within an environment, and root maybe not so much on a Windows machine. These are users that you would potentially find within a Windows environment, within the Active Directory environment. There's definitely, but very, very likely to be users with these names here. And we see that somebody from the same IP is constantly trying different users and failing. So that's very, very suspicious. Yeah. Anybody not clear on why that would be suspicious? It's pretty suspicious. So you could see over here also how the logs are formatted, right? I put it in a table, but for a good reason. By putting it in a table, rather than the way we had those logs formatted, going down, instead by looking at it across, we're able to kind of like see how all of this data stacks up and how it compares to each other much more easily than if we would just be looking at individual logs. So I didn't mean to scare you before with all those logs. Oh man, we're way over. I didn't mean to scare you before, but these are because that's not how we would actually look at the logs. Ultimately, we would put them into tables like this. But just to kind of like show you what those logs look like. So anyways, back to this, you could see that this is pretty suspicious. We wouldn't expect this to happen. So how would we pull that data? How would we find out about this, right? That was your question about correlations, right? This is where we get into that. So SIEMs are basically like these big databases. If anybody's familiar with SQL, every SIEM is the same, is working on these like big data structures where you have all of your logs are stored in these structured formats by time, right? If you notice the first column over here is this timestamp. Just about, there is another type of, not exactly a log, but a static data set that won't include a timestamp. But in general, your normal everyday logs are going to be time series. They're going to be time-based because you want to know when that event happened. That's one of the most basic questions that you need to ask is when this happened. You could even knowing over here, we were able to see those 7 logs happened within just a few seconds. And so that timestamp is vital. But they're all database. They're all logs that are stored in databases. As analysts, we query the data to find patterns, correlate events, and generate alerts. And we all use all the SIEMs out there use SQL-like languages. In XIM, we use XQL, Splunk uses SPL, Sentinel uses KQL, IBM QRadar uses AQL. Here's a couple of examples of those different languages at work. So this is an example in Splunk's language. This is in XQL. And here's one in KQL. Basically what we're looking at over here, we're going to the Windows event log, the security events in particular, because there's actually quite a number of different event log types. So we're looking at the security events. We're looking for the event ID 4625, right? And logon type 3. Okay, we want to look at all the logs of that type that happen within a span of 5 minutes. And then we want to kind of group them together and know how many times there were failure attempts, which users were attempted, what was the source IP, when it happened. And then we want to know, basically, the last thing we want to know is if it happened only one time, after you kind of like group those events, if it only happened one time, there was like one failure event within a 5-minute period, we don't really care about it. But if there were 7, that would be something interesting. So we're kind of like filtering out over here more than 5. And then we're just sorting it. So that's pretty much the same query that we're doing in all these different SIEMs. Yeah. And this is basically how a result set might look. So you have your time, you have your source IP, you have counted the number of failed attempts and the users that were used. And that basically tells us this is a problem. Yeah, is that clear? Sorry, I'm trying to rush it because I know we're over time. Okay, so for remediation, sorry, I can't mute him. So we spoke a little bit before about, so basically we would have an alert with this information telling us that, that we'd have this source IP that had 7 failed attempts with various users. We want to know about that. We're going to get that as an alert with that information right there. Obviously, there'll be other information as well in an actual SIEM, but this is the core information that we would want to know. And then now it would come to remediation. So we have 2 options for remediation. We can use automation. We can use an analyst. And these are completely different ways that you can remediate. Let's say if you're using automation, for instance, in option 1, the automation will get the alert. It'll extract the source IP. It'll send out a request to the firewall and add a rule in the firewall to block that IP and close the alert as a true positive that was remediated and done. That's one option. Using a SOAR. SOAR is a very popular tool today, a very important tool today because you can see that how an analyst doesn't have to deal with an alert like this, right? It could be that this is an actual true positive, and the analyst doesn't even have to deal with it. So that kind of like takes down the number of alerts and incidents that an analyst has to deal with. That's really important. The other way is that the analyst can take care of it. An analyst can examine the alert data, investigate the source IP, say, hey, that source IP actually belongs to one of our vulnerability scanners, and this is a false positive. It's a benign. The alert was a mistake, it's false positive, and then they'll move into fine-tuning the alert and, let's say, filtering out that particular source IP because we know that's from a vulnerability scanner. This way it won't fire again. Okay, and that's pretty much it. The key metrics that we use in the SOC are mean time to detect. How long did it take to detect the event, that the event happened? How long did it take to resolve the event once it was detected? And how many false positives are we actually hitting? So that's why fine-tuning is so important. One of the reasons, so again, there's challenges to being an analyst. We have alert fatigue. If you're having to deal with so many alerts, you can imagine that we have 15,000 users, 70, 80, 90 terabytes of logs. We're going to have a ton of logs. So being able to kind of like having to go through all the alerts that are generated would just be terrible. That's where a source steps in and kind of like alleviates that burden on the analyst. There's also log overload. You saw the different types of logs that we have. Trying to filter through all those logs, again, 90 terabytes of logs is billions of logs. So having that many logs can make it very difficult to find things, but with practice, you learn how to do it. Yeah, go ahead.
How much today is are using rule-based analysis versus AI?
We're mostly using correlations, so rule-based correlations, and AI is coming into the SIEM. We are seeing it more. It's becoming a bigger part of the SIEM as time over the past year or two. It's started to become introduced into the SIEM in bigger and bigger ways. We're seeing it now. They've made some very interesting strides in it. Also, another way we have, let's say, phishing alerts, where a user might report that something was phishing, and then we'll take a look at the email and see if it was actually phishing. So now we actually utilize AI to kind of give us a preliminary, like, based on some factors, this doesn't actually look like it's phishing. So just kind of a quick overview that helps us to speed things up. And it's becoming more. It's definitely becoming a bigger and bigger part of the SIEM. The last thing is complexity. You saw logs come in all those different formats. So you need to really have expertise in order to be able to like get them into the SIEM, to be able to make them readable, usable by analysts. That's an entire job title. So we've spoken about rule tuning. We've spoken about SOAR. The other thing is threat intel. Threat intel is like we use indicators of compromise. So like IPs that are known to be malicious, hashes of files that are known to be malicious. We kind of take all that data, we put it into a platform, and then we kind of ingest it. So like Intel 471 will gather all that data, and we'll ingest that data as a feed from Intel 471 and use that to enrich our logs. So if we see let's say that brute force attack is coming from a known bad IP that we know that it's bad because we have an IOC from Intel 471 telling us, hey, that's a bad IP, then we would know that that's pretty severe. And that's it. That's everything. So if anybody has any questions, happy to answer, but I know that I'm about 10 minutes over time. So that's anybody that doesn't have any questions, though, thank you very much. Sorry that it went over time. And that's it.
Thank you, Yitzhak.
Thank you.
Yep. All right. Have a good day.
Thank you. Good night.
Yep. Good night. Bye.